Hello, so this is going to be a quick video that kind of walks through the theory of how the procedural animation works in my game NOMAD. Again, this is just a theory, so if you want to see more code, a fully commented code, I've got an example that's going to be on itch.io that accompanies this video. So first things first, just going to talk about the inverse kinematics. So the best way to think of this is to think of the leg as a triangle where you've got the thigh and the calf and then a line that connects between the hip and the foot. And we can define the length of the thigh and the calf, and also we can define the distance between the hip and the foot. How it works in this example is that the foot's going to be a moving animated point and the hip's going to be a fixed point. So I simply just use the point distance function to find the distance between those 2 points. So once you have all three of those lengths, you can just simply put them into what's called the cosine rule, or the law of cosines, I believe it can sometimes be called. And that's simply the formula on the right there. So after you've got that angle, which is the red angle at the top, you can use the length there functions in order to define the coordinates of the knee here, and then you only need to just draw a line between those coordinates to draw the leg. Okay, so next up is how to do the 3D effect that you see on the body and the knees. So the way this is done is I simply use a unit vector, or a vector of just length 1. In this case, it's pointing in the direction between the centre of the screen and the mouse. And then I simply just want to extract the horizontal and the vertical components. And that's just done with simple trig. So just cosine times the angle to get the horizontal, and sine times the angle to get the vertical. Or actually interesting at this point is the horizontal here. So in GameMaker, I've just used the function length there x with a length of 1 and a direction, whichever direction you want, just to extract that number there. And you can see it oscillating there between -1 and 1, depending on direction. So the way this is used in practice is you simply times this horizontal component of the unit vector by, well, for example, the X position of the head. So you can see it looks like it moves left to right here. I've also used it on the body, on the scale, the X scale of the body. You can see it squashes as it goes towards one angle and stretches towards the centre. And then we move on to the legs. What I've done here is I've used it on the knee. So the way I've done this is I've just found the distance between the knee and where it intersects the line between the foot and the hip, and then just multiplied it again by the horizontal component, that unit vector, and you can see it gives quite a nice 3D effect of the knee. It might not be too apparent, but it will be later on. So finally, we want to look at how we animate the foot to get the movement, the procedural movement. So the way this is done is I simply have a variable that's counting up to 360. In this case it's going down to -360, but it doesn't matter. And then if you pass this variable through a sine or a cosine function, then you get this oscillating path. And all I've done here is I've used the sine function in the x direction and the cosine function in the y direction, and combined you get this circular motion. And this is this looks a lot like how your foot would move if you imagined it running on a treadmill. And obviously if you combine that with the actual motion of the object, then that will look like it's running. So I can demonstrate this with the leg. So here you are. So breaking down the variables here, there's the direction of travel. And you can see here's that 3D effect coming into play. So I'm squashing the knee there, but also the animation itself using the length there X function, which you can see in red there. and as a result it looks like you're getting this 3D procedural motion essentially here. So the other variables involved here are the speed of the travel, which I believe I can increase. The mouse wheel, yep, so there you go. Obviously the faster you're running, the more you want to speed up that motion. And then there's also the gate size, which is essentially the size of the step. And if you look at the red equations there, the gate is proportional to what you times the whole function by. And then the speed of the travel is how fast you make that counting variable count up, essentially. And really the whole trick is just finding a sweet spot where this or these equations match the speed of the object and make it realistically look like it's running. Okay, so hopefully that's demonstrated in theory how it all works. Again, if you want to see how it's done programmatically, I've got an asset on itch.io that should, for all fully commented code, a GameMaker project that should be able to walk you through in better detail how it all works. And if you'd like to look at the game, obviously as well, this is on Steam right now, called NOMAD. But other than that, thank you for watching.